Hi everyone! We from Pascal.
We will decrypt the message for set G using the 3 different matrices.
My name is Ahmad Muzaffar bin Jalil. I will find the K inverse of K1 using the adjoint method to decrypt the message.
Hello, my name is Anurul Amin bin Azman, and I will help Muzaffar to find the inverse of K1 matrices.
Hi, my name is Nur Alia Danisha binti Ibrahim.
And me, Nur Atika binti Abdul Rahim.
So we will find the inverse of K2 by using
ERO method.
and to decrypt a message.
My name is Anizulaika and my name is Siti Fatimah binti A. Rashid. We will find the K3 inverse and decrypt the message using ERO method.
To find the K inverse of K1 using the adjoint method, for the first step we have to identify the arrangement of adjoint of K1, which is C11, C12, C13 and C14, and until the 4th row. For the first step, we have to transpose the original of the adjoint of K from the row 1 into the column 1. And the second step, we have to find the cofactor for every number in the matrices. The minor of the matrices we are obtained from the 4x4 matrices, in which we ignore the first row and the first column. And then from that we obtain the minor of C11, which is 215, 232 and 413. For the cofactor of C11, we have to find the determinant for each of the cofactors. For each of the cofactors, we have to find the determinants. The determinants of the cofactor C11, we have to do the cross multiplying for the each number in the row 1. For example, 2, for number 2 in the row 1, we done a cross multiplying, which is 3 times 3 minus 1 times 2, and we got 7. So the step is repeated. The step repeated for every numbers, and we got the answer of determinant C11, which is negative 34. And it's done the same for every cofactors in the number of matrices of K1. So the next step, after we find all the cofactor of the adjoint of K1, we have to find the determinants of the original K of 4x4 matrices, which we obtain negative 65, and negative 65 will turn to 1 over negative 65, which that will times with all the cofactor that we obtained in the adjoints of K1, and from there we obtain the K inverse. In the given P, which is 4x4 matrices, will be times to K inverse, in which we have to find the codes. But P, the 4x4 matrices, in the times the K inverse. As you can see, the first row will be times the first column of the K inverse, and it will obtain the first number of P K inverse products. And the steps was repeated until all the number are obtained. As you can see again, that the number was too big for which is not a whole number, and this 4x4 matrices is a wrong code, and is in which we cannot refer to.
Next, we proceed with K2, where we have to find the inverse using ERO. So there are 16 steps to get the inverse, but when we reach until the 4th step, we found that the numbers in row 4 becomes all 0. So this shows that when we want to find the determinant, the answer will be 0. So when the determinant is 0, the inverse of K2 will not exist. So the answer for this message is not correct because the K2 does not have inverse. So we proceed with the K3.
Okay guys, this is the K3 matrices and we need to find the inverse of K3 using ERO method. So there are 16 steps to find the K inverse using the ERO methods. So this is the K inverse that we get from the ERO methods. Okay, for the last step, we need to multiply the P matrices given with the K3 inverse that we get before. We need to multiply the first row and the first column and so on. So we get the number code is that. And after that, we encrypt the code and we get mathematics magic. So that's all from us. Thank you.
Along.
Yes.
I got the answer for the 3 matrices and one got the answer mathematics magic. Is that right?
Oh, yes. That is the answer. Mathematics is magic.